A really important use of systems of inequalities is in what we call linear programming. It's actually just using system of inequalities to solve real life problems. Because if you really think about it, most things in life aren't just, equal to this or anything like that. We usually have less thans or greater thans. And when we're trying to maximize profit in real life, that's a great example of why you would use an inequality instead of an equation. So in this example, we have a potter who wants to make and sell serving bowls and plates. A bowl uses 5 pounds of clay. A plate uses 4 pounds of clay. The potter has 40 pounds of clay, and he wants to make at least 4 bowls. The profit on a bowl is $35, and the profit on a plate is $30. How many bowls and how many plates should the potter make in order to maximize his profit? So, what we're looking for are the number of bowls and the number of plates. So I'm going to be very creative, and I'm going to call B the number of bowls, and P is the number of plates. Now let's think about some things we know. Well, first off, I know the number of bowls has to be greater than or equal to 0. We can't make negative bowls. Our plates as well have to be greater than or equal to 0. We can't have negative plates either. Now something else I know is that we have a limitation of how much clay we have. He only has 40 pounds of clay. So we need to use as much of it as we can, or we can't go over that. We only have 40 pounds of clay. Now if I only have 40 pounds of clay, I need to look at how I'm using that. We use 5 pounds for a bowl, so 5 pounds for each bowl, and 4 pounds for each plate, and there's a maximum of 40 pounds, so I need that to be less than or equal to 40. We also know that this potter wants to make at least 4 bowls. Maybe he already has an order for those. So his number of bowls has to be greater than or equal to 4, because he really needs to at least make those. All right. Now that I have my constraints, here are some reasonable constraints, and then these were given information. This was the need at least 4 bowls. We have inequalities that we can graph. Now on my graph, I'm going to make, let's see. Let's make the x-axis be B for bowls. And I'll make the y-axis P. Now, I'm starting mine at 0 because I know this constraint is that I need to make sure everything is positive. So I'll just use the first quadrant. Now, we know we need at least 4 bowls. So here's where the B values are 4. That means we have 4 bowls. So we need to make a little boundary line here, because we want more than 4 bowls. We want this side. We're shading greater than, so that is that way. So that'd be everything this way. Now, we need to take into the constraint of how many pounds of clay we have. Now, I'm going to use intercepts to graph this. When my number of bowls is 0, that gives me 4p equals 40. That would mean I'd have 10 plates. So when the number of bowls is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I'd have 10 plates. When the number of plates is 0, I can make a total of 8 bowls. So over here, 4, 5, 6, 7, 8. This would be the 8 bowls. Now I just need to connect my dots. So this is my boundary line for what I can make with only that 40 pounds of clay. And we can make less than that, so we can make everything in here. but not more than that. Do you see where they're crisscrossing? That is the solution to our system of equations, or inequalities. That is what we call a feasible region. That means that our solution could be anywhere in there. But the points of intersection, these vertices of that figure, are key points. So let's write down what those points are. This one is 4, 0. That's really just making that minimum of 4 bowls. And this is bowls and plates. The next one is 8 bowls and 0 plates. The next option is going to be 4 bowls and 5 plates. Now I need to see which one of those would give me my maximum profit. So I'll need to look back at the problem and find out how much each bowl and each plate make me. The profit on a bowl is $35 and the profit on a plate is $30. So that tells me that I get $35 for each bowl, and then I'm going to get $30 for each plate. That is my profit function. That's my objective function. This is what I'm really looking at. I'm wanting to look at my profit and maximize it. Now, to maximize it, it's going to be at one of these 3 places. So I need to plug in each of those points and figure out what the profit is for each point. If I plug in 4, 0, 35 times 4 bowls. That's the minimum he wanted to make, by the way. So that would be 140. I believe, yes. Now, what happens if we make 8 bowls? 35 times 8 plus 30 times 0. Well, that's really just double that. So that would give me 280. Now, what happens if I make 4 bowls and 5 plates? So here's the 4 bowls. Then add to that the 5 plates. That's 150 plus 140. That would be 290. So really, this is the minimum, because it's just making that minimum of 4 bowls. This is the maximum. That's the maximum we can make using only that 40 pounds of clay. So, how many bowls and plates should the potter make? The potter should make 4 bowls and 5 plates to maximize his profit.